Maxym Iaroshenko. I am co-founder and senior software engineer at Eltrino company, and I am pleased to be a part of such a great Meet Magento event in beautiful city Warsaw. And stay here in front of you to highlight something is very fascinating and exciting in Magento world. Everyone here knows that Magento out of the box is working with MySQL. But since release of Magento Community Edition 1.6 and Magento Enterprise Edition 1.11, everything related to database interactions was improved by Magento folks. So Magento is not anymore tied to MySQL only, and could potentially work with any relational database management system, for example, like SQL Server, Oracle, PostgreSQL. More than a year ago, at Magento Developers Paradise Conference, at that conference, Andrei Tserkus from Magento company already announced that Magento starts running on multiple relational database management systems, or shortly RDMS. And it really happened. Magento team has refactored resource models in the Magento core, cleaned up them, so they contain only non-RDBMS specific code. And the RDBMS specific code was moved into resource helpers. So all this enables to add support for other RDBMS with less efforts, since most of the code is in the resource models. The refactoring of the resource models has backwards compatibility. So old Magento modules will still work using MySQL, which is good, of course. I feel that I should introduce myself shortly, so you will be confident that I know a bit about the topic I would like to present today. 1 year ago, I was still working at Magento company, and what a coincidence, I am such a lucky guy that I was involved into development of RDBMS support. And since that time, I was pushed by it everywhere I go. I have even tried my job. But even that didn't help. So, as you understand, I am deeply involved into this topic and working on one of large projects running on Microsoft SQL Server. And another project we start on Oracle server. So one of the questions you might want to ask just right now, and I did the same a few times in the past, why? Why does somebody ever need something different to MySQL? Answer might be obvious for some of you, and absolutely incomprehensible and unclear for others. In reality, there are multiple reasons for enterprise business to choose solutions different to MySQL. Also, there are some technical differences which might work better for different purposes. First of all, when it comes to security standards, service-level agreements offered by different companies behind existing databases, support packages, and different internal corporate policies. You can say nothing against that, because it's their business, and probably pretty large one if they have such policies at all. And they most likely know what they are talking about, so you either accept it as is or lose the project. If you're lucky that you can argue and convince them to use MySQL to save on implementation cost, you probably should do it. Because implementation won't be fast and easy. However, there are some technical advantages different database offer. So even from technical standpoint, it might have sense to recommend solutions different to MySQL. Let's look into all this in details. Let's start with our agenda for the presentation. I would like to describe you a few key topics. First of all, how database layers works in Magento. Review role of the resource helpers and all advantages we can get from Magento. Discuss how to create new Magento database adapters. Then we will slowly go to common problems and solutions during integrating with non-MySQL databases. And finally, review available features in other RDBMS. In Magento, we have models which contain all business logic. They are directly communicating with resource models, which are responsible for delivering data required by models from deeper layers. Resource models are using resource helpers. And as you can see, resource models are directly connected to DB adapter, which can be found in lib variant DB directory. DB adapter itself is working with driver, and the driver at the end is connecting to the database to retrieve data from it. And logically, we have to mention responsibility of database adapter in Magento. There are a few things database adapter has to do. It has to connect the database, perform platform-related operations, for example, adding indexes and foreign keys, provide platform-related queries, and provide management of nested transactions. We can see how it works on simplified sample, based on working with customers' data. We get well-known customer address model, which work with customer address resource model. And we need to receive customer's name, which consists of first name and last name. So we need to use, for example, it's simplified method, we need to use group concat from MySQL. But this function exists only in MySQL. So in resource helper, we should create a method to emulate group concat function for any other database. For example, let's call this function group concat prepare. It's taking variant db select as an input, extending it with correct syntax for the database we are using, and returning it back. So our request to the database will not have group concat itself, but still it will have right logic we need. Also, we need to create custom resource model for our database, which will use our method from resource helper to prepare requests to the database without group concat. So it will call group concat prepare method we have just created. In the next point of agenda, let's see the role of resource helpers. The role of resource helpers is quite important because some things that are dependent on the database features cannot be covered by the adapter. Like in the sample we just reviewed with group concat. So primary role of resource helpers is to get the same result of query execution for different databases. So resource models will work quite the same for different databases and operate with the same result sets. But internal database queries might be quite different. For example, in MySQL group concat called group concat, but in Oracle database it will be list tag instead. On the next sample, I want to show you resource helper usage. You can see code snippet describing how resource helpers can be called by resource models. As you can see, in resource models we have where statement, and calling catalog resource helper method get is null not null condition, and also how this method is implemented in resource helper itself. What do you need to do at support of a new database? First of all, you have to create a new database adapter which will allow interactions with the RDBMS you are going to support. It should implement native Magento database adapter interface, and resource models will be able to use it. Then you have to define adapter class in specific resource model and properly configure it in Magento. But you should choose driver for your implementation, and we recommend use PDO DB-libs. To enable a new database layer, we have to create a new adapter. We need to use variant-db adapter interface, and based on it, create new class, for example, variant-db adapter XRDBMS, where XRDBMS will be name of your database. For example, Postgre or Oracle. Class name of the adapter can be different to the sample, but we have just decided to use existing naming and extend what Magento offers. If needed, you have to create a new statement class variant-db statement XRDBMS. Also, you should create a new resource type database for core model. For example, let's call it MH core model resource type DB XRDBMS, and new resource helper MH core model resource helper XRDBMS. The next step will be about defining a new adapter class we have just created in the global Magento config. On the slide, you can see that we need to define connection type, which uses connection to specify a database, and specify adapter class name. In general, you are free in your decisions and naming conventions, and should check how similar things are defined for MySQL databases. Next slide is illustrated defining connection in the Magento configuration file. Specifically, we need to define database connection properties, like host or IP address of the database, username and password, which is quite similar for all databases, including MySQL. Next, we have to define database name. Specify init statement that will be executed immediately after connection to the database. For example, you can specify char sets, time zones, etc. And we are getting the most interesting part, where we define model which will be used as a name of your resource helpers and as a prefix for Magento install and database upgrade scripts. Type is connection type we defined on the previous slide. So system will be able to link both. And PDO type is operating system dependent setting, which will define which driver or library will be used to perform low-level operation with the database. In our sample, we are running on Linux environment and going to use DB-lib to connect to Microsoft SQL. As the next point of our presentation, let's review common problems and solutions of integrations with different databases. There are two main things I would like to describe you today: differences in transactions and differences in SQL syntax. Transactions are quite important database stuff used by Magento everywhere. And what do we know about differences in transactions in different databases? I won't go deep into details because I just won't have enough time to describe everything. So it's a subject for a separate presentation. But I need to say that almost all databases have some differences in transactions logic. Especially that's related to transactions isolation level, like repeatable reads, read committed, etc. Before starting development of a new adapter, be sure that you learn and understand such differences. The main problem on our way to support different databases is differences in SQL syntax. All RDBMS are using similar SQL language, but different RDBMS have different SQL dialects. I'll refer multiple times to the group concat sample we already briefly reviewed. But I need to mention that group concat is just one differences, and there are many more other different things. And a few of them I would like to show you to describe some of issues you might spot when working with databases other than MySQL. On the current slide, you can see we cannot just use asterisk in select statement on Microsoft SQL Server. If we need to have group by clause in the query, so query to read products from the database needs to be slightly transformed. And we have to use group or aggregation functions to read values that we need, because otherwise we'll get an error message from SQL Server saying that column is invalid in the select list, as it won't understand what it should do with grouped rows. Next issues is already mentioned group concat to read customer's full name. On Microsoft SQL Server, it's completely different query that will use subselect to read both first and last name of the customer, and then for XML path syntax to concatenate it, and finally function stuff to remove extra space in front of the same name we added during such concatenation. And at the end is grouped to have just one customer's name instead of multiple copies for every row in the database. Another issue is related to dealing with dates in MySQL and MS SQL databases. For example, we need to calculate how many days are between two specific dates. In MySQL, we'll use two days functions and find the differences. But in MS SQL, we need to execute datediff function that will return us what we are interested in. By the way, the one of small technical advantages of different databases I mentioned offer. Nextins is very often used in different queries when we read just part of result set. For example, to show a page of customers in the grid. That's query with limit. So if we need to read a few rows with any offset, is quite easy in MySQL, but turns to a bit more complicated query in MS SQL. With subquery, we read some results from a table and then aspire apply specified offset. We already reviewed how database layer works in Magento, highlighted the most important things related to general structure, run over some common issues and possible solutions to give you understanding of what might happen, and show general way to resolve issue. When you will start integrating of another RDBMS on your own, you will spot more issues like that. And you will definitely find some of our samples helpful. We also reviewed the role of resource helpers in Magento when working with different databases. So you should understand now better why Magento did the great job to have them stand alone. And we even reviewed how to develop your own adapter to connect to any new RDBMS you need to support. So let's go forward and highlight some of available features in other RDBMS that might be useful for you and give either performance increased or just make life easy and avoid extra coding that will be required if we won't use them. This list is just a sample, and I will cover just some of such things. So you should understand that before starting. You have to investigate all possibilities and features of any new database you would like to use. Some of such things are analytic functions, which are available anywhere but not in MySQL. Materialized view, available in Oracle and DB2, allow functions like pivot and unpivot. About analytic functions and their implementation in different RDBMS, you can read a lot in different articles. But I want to tell you about Magento features, where use of analytic functions will significantly increase performance of the application and reduce lines of code in models responsible for data processing and preparing of required results. I'm talking about reports, various indexers, like indexers for catalog price rules, user permissions, etc. These Magento models, and some other as well, could use analytic functions, and if they would do so, it will simplify their PHP implementation and maybe make them faster, because some of their logic will be executed on the database layer, which is normally faster and less loaded. Similar statement applies also to materialized view. Normal database view is something like a virtual table, representing results of a database query. When a query against view is executed, RDBMS converts it into requests to underlying tables. So all data is fetched on the fly, causing extra load on the database whenever query gets executed. And materialized view takes a different approach, in which query result is cached as a concrete table and updated from original tables from time to time. It reduces load on the database side and significantly improves speed of queries reading data from such materialized views. Materialized views could be also used for reports, indexers, and anywhere else where we need to get calculated data by one click. It will make them working without required re-indexing or rebuilding. So many operations which triggers those functions will work way faster. And what's even more interesting, there will be no possibility to development errors, and there will be no need to write all those reindexers, observe events to run that, and pay attention to all new methods that you are going to add, and that will deal with such data, even if for some reasons it works on low database level directly. For example, if you have to develop fast importer that will be imported products directly into the database, you will have to run reindexing processes, but with materialized view it might be not necessary. Magento won't need to take care about that data and keep it actual at all. Database will do it on its own, on the fly. Everybody who knows Magento also encountered with an attribute, entity attribute values structure, or shortly EAV, used for a lot of Magento entities. In last Magento releases, Magento team tried to optimize performance of EAV data model by adding extra indexes, flat tables, or even completely moved some entities, for example, orders, to flat table structure. But it won't be really necessary if MySQL would have pivot statement. Pivot is table transformation which enables rotating of a table or result set. In Magento world, we can easily use it to pivot data set read from multiple EAV tables and finally get a result which will be quite similar to flat table structure. You can use that advantages of a database engine in Microsoft SQL, Oracle, and some other databases. It might be just called differently there. For example, it's called cross-tab function in PostgreSQL. But unfortunately, it's still not available in MySQL. There are some workarounds to produce similar results on MySQL, but they are not very friendly and uncommon and therefore not recommended. As you can see, there are a lot of different things you can use in your own custom implementation, and you shouldn't stick and just copy MySQL adapter, especially if you care about performance and cleanliness of your code. We would like to reference one good article, which was written by Andrei Tserkus. I mentioned him at the beginning of the presentation. I feel it will be really interesting for you if you plan to do make first integration without MySQL. Okay, thank you. Do you have some questions?